The new topic सभी को देखना है. Okay, today we are seeing the topic that is a Cauchy Homogeneous Linear Differential Equation. Okay, that's come under the differential equation. So we'll see here now an equation of the form. If you see, the equation is of the type x to the power n, another derivative of y, this is dny by dx to the power n, plus a1 x to the power n minus 1 d raised to the power n minus 1 y upon dx raised to the power n minus 1, then plus a2, here it is n minus 2, we are having power of x, then we are having n minus 2 derivative. So likewise, if you see here, this is the x is having the power 1, it is the first derivative, plus an into y equals to x. So if you see, look at this equation and observe it. So the power of x is the same as the order of derivative. Okay, here the power of x, what is it? N minus 1, order of derivative n minus 1. So such equation is called as the Cauchy Homogeneous Linear Equation. Now why it is a homogeneous? Homogeneous, why it is? Because the degree for this one, it is what? 1. Degree for this, it is what? 1. So degree for the each term is what? For each differential coefficient, it is what? 1. And it is also linear. Linear means it is a degree is what? 1. Okay. And homogeneous means we are having the this is having the power n, this is having the power n, same power, this is having the power n minus 1, this is having the order, what is it? N minus 1. So therefore it is called as the homogeneous. Okay, so it is a Cauchy Homogeneous Linear Equation. So we write down the first of all the symbolic form for this one, where you have to just note down that x is a function of x only, a constant term, and this a1, a2, an that we are using here, okay, they are constants. So how we write down the symbolic form? That will be here then x to the power n d to the power n plus a1 x to the power n minus 1 d to the power n minus 1 plus a2 x to the power n minus 2 d to the power n minus 2 plus so on, this goes here, then n minus 1 xd plus an and y outside equals to x. This is the symbolic form for the Cauchy Homogeneous Linear Equation. Is it okay? Now we have to solve this equation. So what we do here, we convert this equation to a higher order equation with constant coefficient. यहाँ पे जो coefficient है, that is variable coefficient, because we are having the x to the power n, x to the power n minus 1, x to the power n minus 2. So this is the equation with the variable coefficients. Okay, but we convert this equation into the constant coefficient and then we'll solve it by the previous concept that we have seen. Okay, अब कैसे करते हैं उसको convert, we'll see here. To convert this equation into the higher order equation with constant coefficient, for that I put x equals to a raised to the power z. Okay, अब इसका मतलब क्या है? अगर मैं x equals to e raised to the power z पुट अप कर रहा हूँ, मतलब I am changing the independent variable. यहाँ पे independent variable क्या था? It is x. नीचे में जो आता है that is independent variable. Okay, with this substitution now I am changing the independent variable. It will be a x equals to e raised to the power z, means z will be the independent variable now. Okay. Now I take the logarithm to both the side. What will be it is? Log x equals to log e to the power z. Log e cancelled. What is left? Z. So log x equals to it is what? Z. So we can substitute x equals to e raised to the power z, or maybe z equals to log x. It is one and the same thing. Now after that I substitute xd equals to it is d1. Now what is d stand for? D stand for the derivative with respect to x. The d1 stand for the derivative with respect to the z. Okay, we have changed the independent variable, so that's why we are taking the new independent variable, that is z, that is d1. The differential coefficient as d1, that is ddz. Now I replace xd by the d1, then I replace x square d square by d1 minus 1. Okay, x cube d cube by d1 minus 1 d1 minus 2 plus so on. I generalize x to the power n d to the power n, that will be replaced by d1 minus 1 d1 minus 2 plus so on. कहाँ तक? d1 minus n minus 1. देखो यहाँ पे क्यूब है तो यहाँ पे क्या है? It is 2. यहाँ पे स्क्वायर है तो it is what? 1 लेस आ रहा है. So यहाँ पे to the power n है तो यहाँ पे क्या आ जाएगा? It is n minus 1. Is it okay? So this you have to use here, this quantity, and then substitute in the equation number 2. So we'll substitute that here. This quantity, that is first term x to the power n d to the power n, is replaced by this quantity. We have this one plus so on. Then I replace the quantity, the previous quantity, that is x square d square by the d1 minus 1, that is d1 minus 1, xd by it is what? d1. So if you solve it, this complete equation, the variable x will be completely vanishes and you will have a constant coefficient. So this will be the higher order differential equation which is having the same order that of the Cauchy, okay, but with constant coefficient. Cauchy में वेरिएबल कोएफिशिएंट था, दैट इज x, यहाँ पे कांस्टेंट कोएफिशिएंट आ जाएगा. एंड वी नो दैट हाउ टू राइट डाउन द सॉल्यूशन फॉर दिस इक्वेशन, दैट इज y इक्वल्स टू CF प्लस PI. कॉम्प्लीमेंट्री फंक्शन निकालते हैं, पर्टिकुलर इंटीग्रल निकालते हैं, दोनों का कॉम्बिनेशन गिव्स द सॉल्यूशन फॉर दिस हायर ऑर्डर. ओके, एंड नाउ लेटर ऑन रिप्लेसिंग द क्वांटिटी x इक्वल्स टू e raised to the power z and z equals to log x to get the solution of given differential equation. ओके, सो हम इसके अंदर क्या करते हैं, गिवन जो इक्वेशन है कॉची लीनियर इक्वेशन, उसको हम कन्वर्ट करते हैं हायर ऑर्डर इक्वेशन विद कांस्टेंट कोएफिशिएंट में. एंड देन नॉर्मली जैसे हम सॉल्व करते हैं वैसे ही आपको सॉल्व करना है. जस्ट आपको याद रखना है कि इंडिपेंडेंट वेरिएबल चेंज हो रहा है, तो सॉल्यूशन आपको फिर इंडिपेंडेंट वेरिएबल में लिखना है. जैसे हम अगर रूट्स हमारे आते हैं +-1, तो हम कॉम्प्लीमेंट्री फंक्शन कैसे लिखते हैं, CF इक्वल्स टू C1 e raised to the power x प्लस C2 e raised to the power -x, वेयर x इज व्हाट, इंडिपेंडेंट वेरिएबल. अब इंडिपेंडेंट वेरिएबल चेंज किया है हमने, तो CF कैसा आएगा फिर यहाँ पे कॉम्प्लीमेंट्री फंक्शन C1 e raised to the power z प्लस C2 e raised to the power -z. मतलब x इज कंप्लीटली रिप्लेस्ड बाय व्हाट, z. विद दिस सब्स्टिट्यूशन, दैट इज x इक्वल्स टू e raised to the power z and z इक्वल्स टू log x. ओके, थैंक यू.